choose one.
Let's jump right back into it. So in terms of this video, what we're going to do is look at different ways of viewing the data and then transforming it. So the very first way of actually viewing the data is actually typing the function called view with the capital V, I-E, W. And when I run this, it's going to pop out. It's going to show me what we saw earlier. Okay, so this data frame, the data, and so on and so forth. So that's one way of viewing the data. What I love about Positron is that you can see all this information in the this little tab here to the left, and it's very functional, you know, in terms of the account, the month, the year, and so on and so forth. So that's one element of viewing our data. The next way of viewing our data is actually, it's very straightforward, just for us to see the dimensions of our data. So we can just type the function dim. If we want to quickly just see the number of rows, number of columns, okay? Or when I run this cell, as you can see, it doesn't show up, but it is here. It's right here. So that just tells us the number of rows. There's 821 transactions, okay, and 7 different columns. We saw that there. I just didn't highlight it. It's right here. Okay, same information. And then from there, last but not least, there is the glimpse. So this glimpse function is from the dplyr library. Okay, glimpse, if I can spell it. Okay, glimpse. Whereas dim and view are base within base R. So if I run this, I can actually get a better glimpse of the actual data set. Again, 821 rows, 7 columns. This gives you a breakdown of all the data types, all the different data types. There are other ways of actually viewing the data, but I'm just going to highlight these 3. So in terms of this glimpse, you see it says double character, double character, character, double character. So character is just a string of information, whereas a double, we can consider that to be what you might have seen, double precision floating point number. It's our standard numeric type for decimal values. As you can see, this is date is a number which is not correct. It's not ideal, and we'll fix that in a little bit. So these are the different ways of actually viewing our data once we bring the data into our data set, into our environment. But before we continue, I got ahead of myself. There's some questions here. Didn't see. So when it comes to the data frame, a data frame is a 2-dimensional table-like structure that has columns and rows. Okay, it's a 2-dimensional table-like structure that has columns and rows, where the columns represent the variables and then the rows represents the observations. Okay, and then when you see the glimpse, we already talked about this, but the dplyr represents our standard numeric type for decimals. Okay, numeric type for decimals. Okay, so finally, transformation. So transformation is the process of cleaning, manipulating, reshaping the data for either analysis, it says analysis, and or visualizations. In this class, we're going to primarily focus initially on visualizations, and as time progresses, we'll get to analyses. So I guess we can just say in our own words, transformations allows us to clean / modify data for analysis and visualizations. Okay, good. So with that being the case, let's talk about some different ways of transforming our data. So our very first thing I want to highlight is this function called mutate. Okay, this function called mutate. Mutate allows us to create new variables within our data frame. Mutate allows us to create new variables within our data frame. Okay, since that's the question below, might as well just write that out now. Mutate allows us to create new variables within our data frame, okay, or maybe modify already existing ones. What I mean by that is that date, for example, right, we saw was a number. That's not a date. So what we can do is say go into date and utilize this function that's found in lubridate, as, we can use the as date function. And that allows us to essentially turn that date variable into an actual date. We'll see that in a little bit. 1 second. The next thing that we can do is take that date variable, create a label. Okay, I'm gonna say label is true. Okay, if it's not true, it'll be a number. And then last but not least, we're gonna say that year is just gonna be the actual year. Okay. And I'm gonna add something that's not in the notes. I'm gonna call this mod because there's already an existing month and year variable. So let's go ahead and do this. Run this. Boop. Go to our view, and now you can see that the date variable is no longer a number like we saw in coffee. It's a legitimate date. And then we can see here towards the far right, you see it says mod, month mod, year mod, because now this is now a month and this is the year. Okay, this is the year. Again, the reason why I knew that because I already knew that these variables already exist. Okay. So you can see that year mod has the same distribution as year, and month has the same distribution. Month mod has the same distribution as month. Okay, so that worked. So why does month date label true return Jan, Feb instead of 1, 2? Because we're specifying the label. We are specifying the label in the function's argument. Okay, so if we wanted numbers, we can legitimately just remove this or say this is false. All right, so something else to note is that there's some moving pieces. There's this thing and this thing. I think we already talked about this. This is the assignment operator, right? This is the assignment operator, whereas this is a pipe. Okay, this pipe operator allows us to make better looking code. Long story short, better looking code. Because without that pipe operator, it would look more cumbersome, okay, in terms of our code. It looks more cumbersome. All right, so we'll see an example of that in a moment, okay? So here, we're going to talk about the further pipe using the pipe operator, but we're going to select certain variables. Instead of selecting the variables that are in the data frame, we will say, for example, we will want only a few of them. So what we can do is select the following variables: date, comma, month, okay, comma, year, comma, amount, and description. Okay, I don't want to deal with the amount, description. So when I run this, okay, I have the information that I want. But notice that in the very original data frame, this mod 1, it was in a particular order. But now that I use the select function that allows me to select the columns, okay, I'm able to specify the order. All right. So when it comes to utilizing, again, this pipe operator, the reason why we prefer it is because if we were to have to do a select, then a mutate, and another select, you know, that data can get complicated. It would make our code look something like this. It would be nested. So it'd be like a select, then a mutate. If I can mutate, coffee, df. And then that look cumbersome. It's harder to read. However, if we make it look in the following format, select, coffee, the data frame, and then we pipe it into, let's say, I'm just going to make this a formal R chunk. If I pipe it into mutate, I do a mutate, and then I can pipe that into, that's Command Shift M to keyboard shortcut, select, and then I can pipe it again into another mutate. So then I can read it easily that I'm mutating something, I'm creating some new variables, I'm selecting columns from those columns, and I'm then mutating. So it makes it easier to read rather than looking at this nested format. All right. So with that being said, learning moment 6. I need to emphasize the learning moments more. I was learning moment 5, learning moment 6. And this was pipe and select. So not just, okay, and select. The next one is the filter function. Okay, the filter function. The filter function allows you to essentially get rows based on a condition. Okay, keep the rows based on a condition. Okay, so say for example, I want every amount to be greater than 5. I want every amount to be greater than 5, right? But please take a note. This is very this is gonna be an error. Or at least something weird happens. So it says coffee above 5 DF. When I run this, I should have zero rows, right? And the reason for that is because when you take money from an account, it's going to be negative. You're taking money. So what we can do is, because this is a positive 5. I could make it negative, but that's not, I want to modify this, okay? So if I mutate this, and I say mutate, and say amount is equal to, you can pause it and try yourself on how you can make it positive. Ideally, you take -1 and then multiply it by amount. Keep it, it's very sensitive about lowercase. Okay. Now when I run this, I now have my rows 363. So if I want to view this, it's going to be all amounts that are positive, and every amount, if I sort this ascending, all the amounts are greater than 5 because it's ascending to the highest. Don't judge me about the what I spent on coffee. So that's that. Okay. So that's how the filter works. It allows me to filter along the a particular condition. So let's say, for example, I wanted to do a more advanced filter, right? I want to only look at Saturdays and Sunday purchases. Okay. So this operator is the in operator, okay, where it's going to check if these variables, or these not variables, these levels are within the day of the week. So I know that it's going to be Saturday. Look, I do it in double quotes, Saturday. And this in and of itself is then Sunday. We're putting this information into a vector, okay? And then we're checking the smaller subset within this big subset. It's always going to be what you're checking on the right into the actual variable on the left. So when I run this, I'm only going to get weekends. As you can see, this is now, okay, 26. Interesting. Okay, so these are the days that I made purchases on the weekend, Saturday, Sunday. All right. So the N operator allows us to, it's like a membership operator, okay? Returns true if it's actually within the day of the week, okay? Returns true if in the actual end of the week, in the end. Actually in the vector, sorry. Okay. Slash variable. All right. Last but not least, learning moment 7. Learning moment 7. It's the capacity to group by and summarize the data. So we can group by a certain day and then find, or a certain element, and then find the aggregated value for that said group day or month or year. So what we're going to do is find how much is being spent per month in terms of average, as well as in terms of total, and then count the number of purchases. So we're going to group by month. Okay, so the group by allows me to group by the actual month. And then finally, we're going to take the sum. We're going to take the average, which is going to be mean. And then here, this symbolization allows me to find the sample size. This allows me to find the sample size. Okay. So this allows me to find the sample size. This allows me to find the mean. And then this allows me to find the sum. One thing to note is that I'm going to always put NA.remove is equal to true. Because if it's there, if it's missing data, this allows me to still find the sum or the mean. Okay. So this is my resulting table. Okay, this is the frequency, this is the average, this is the total. we'll talk more about these two questions before we do the visualization video. Thank you so much.